Hello, everyone, and welcome to the SOLARISE event for today on the topic of energy storage concepts. I would like to welcome everyone to this conference, which would focus on various important questions surrounding the notions of energy storage, its importance, and the challenges and solutions. So for today, I'm Atman Datta, your host for the day and SOLARISE project coordinator from the Ville de Fourmies. I work on renewable energy and efficiency projects in the Third Industrial Revolution Department, which aims at CO2 neutrality and energy autonomy through various innovative methods like co-creation, public governance, and through the creation of various smart projects like the smart lab I'm sitting in today. So I would like to start with this web conference by explaining some rules of the event. So first and foremost, I would request all the participants to turn off their microphones and their cameras to maintain a constant network. And you can find the controls at the top right corner of your MS Teams screen. For your information, this conference is being recorded, and this recording will be available to all of the registered participants shortly, following a small survey, the links of which will be sent to you very shortly after the meeting. I would also appreciate the participants to express themselves using the various emoticons available in the raise your hand column. So you can find them quite easily on the top right corner of the MS Teams screen. For the guidelines for the question and answer sessions, although we advise all the participants to ask a lot of questions, I advise to begin your questions with a capital Q and a colon to distinguish it from other comments and remarks. I would also request each of the participants who would be invited for verbal remarks or interventions to kindly turn on their camera when they speak, and also their microphones, and kindly turn them off after their turn is over. So I would like to start with a small introduction for our mayor, opening words from our mayor, Mr. Michael Leroux, who started the implementation of the idea or the strategy of Third Industrial Revolution, which is a concept of the Région de France at Fourmies in the year 2015, which is aimed to re-dynamize the city, which was an industrial powerhouse in the 1900s and has declined a bit since. And he's also planning to deal with the prevalent problems of energy poverty, social and economic issues of the city. So I would like to present you a small video.
Bonjour à toutes et à tous. Je suis Michael Leroux, je suis le maire de la ville de Fourmies. Je vous souhaite la bienvenue à cette webconférence co-organisée par la ville de Fourmies et le consortium Interreg SOLARISE. Aujourd'hui à Fourmies, 22 millions d'euros sont dépensés pour les énergies et 39% des habitants sont en précarité énergétique. Ce constat est une des raisons pour lesquelles, dès 2015, la commune s'est engagée dans la troisième révolution industrielle. Une stratégie pour la région Hauts-de-France. Notre objectif, être autonome en énergie renouvelable d'ici à 2050. C'est dans ce but que Fourmies est active au sein du consortium Interreg SOLARISE. Grâce au soutien financier de l'Europe et l'expertise de nos partenaires français, belges, néerlandais et anglais, la ville a pu installer 3 centrales solaires photovoltaïques. Ces 1000 m² de panneaux sont implantés sur des bâtiments municipaux, ce qui permet de sensibiliser et de promouvoir l'adoption de l'énergie solaire auprès des habitants. Mais l'augmentation de production d'énergie renouvelable nous amène déjà à réfléchir au stockage énergétique, un enjeu pour mieux gérer la transition énergétique. L'autoconsommation collective, déjà opérationnelle à Fourmies, est un pas de géant vers l'autonomie énergétique des territoires. Ce montage innovant permet en effet de distribuer et de consommer l'électricité produite localement. D'autres technologies et solutions en faveur du stockage énergétique vous seront proposées lors de cette conférence. Pour terminer, je souhaite remercier tous nos partenaires SOLARISE, les intervenants de l'Université de Picardie Jules Verne, l'Université de Gand, le Pôle Énergie, Énergie de France, Vent du Nord, aux costauds et Enogrid pour leur participation. Vous êtes très nombreux ce jour. Je vous remercie de nous avoir rejoints dans cette lutte contre le changement climatique. Bonne conférence à tous.
So I would like to start by thanking him for his opening words and continue the presentation if everyone can see it. So next, I would like to introduce everyone to Professor Ahmed Rashid from the Université Picardie Jules Verne from Amiens. He's the SOLARISE lead partner and also participates in other international and European projects as an expert in control systems, instrumentation, and solar systems. So he would like to introduce the project SOLARISE to each and every participant. Thank you.
Hello, everybody. I hope you can hear me. Yes, okay. Thank you, Arpan, for your presentation, the smart presentation. This is not the first slide. Interreg 2C's program has, yes, thank you. The SOLARISE project is under the Interreg 2C's program, which is a program under European program ASH 2020. There are 12 partners from and ending in June 21. Next slide, please. So we have 12 partners and 14 observers. There are 3 universities: University of Picardie Jules Verne, University of Portsmouth in the UK, and KU Leuven in Belgium. Next, please. There are observers also, and we have Flux 50 and CAMPC, which are cluster and public body. And we have also municipalities which are supposed to implement solar installation to show the usefulness of solar energy in the north part of France, south of Belgium, south of Netherlands, and south of UK. Despite the lack of sun, it may be very profitable. Next slide, please. So the main objective of SOLARISE is to accelerate solar energy adoption throughout the 2Cs region by identifying and overcoming some barriers, which may be legislative or market and so on, using smart grids, electricity and heat storage, Internet of Things, and energy management systems, proposing cost-effective and affordable solution, implementing innovative living labs, and a series of demonstrations in public buildings, infrastructure, and in households with low-income families. And finally, delivering training tools and roadmaps to and a campaign to raise awareness of solar energy. Okay. Okay, next, please. The main outputs are, there are 8 outputs, main outputs, a guide package. I will try to make it short. Feasibility of potential solar projects, which include buildings and heritage buildings, solar farms, and commercial centers, schools, and so on. The output is also concerning solar installations. As I said, there are 8 installations which will be implemented. A campaign to boost solar power adoption, and finally roadmaps for municipalities to adopt solar energy. Next. Well, we see a combination of different technologies which involved electromobility, solar homes, solar farms, energy storage in electric form or heat form, and of course, smart grid, which has already been presented. So I will stop here and wish you the best for this seminar. Thank you.
Yeah.
Okay, ciao.
Sure. Hi, thanks, Ahmed, for your presentation. I hope everyone and each and every participant gains some perspective regarding the project Interreg SOLARISE. So now I would like to pass on to Professor Jan Desmet from the University of Gand, an expert in renewable energy storage and also a partner in a storage project, which is Interreg STEPS. Now, Mr. Desmet will explain what is energy storage and why do we need it. He will also talk about the work being done in the Interreg STEPS project, which is being developed hand in hand with the LEMCO project, which is undertaken by the University of Gand for a future and for renewable and durable future with the low carbon economy. The floor is to you, Mr. Jan Desmet.
Arpan, okay, thank you for the nice introduction. It will be my pleasure, ladies and gentlemen, to tell you something about the local storage. Arpan, do I take my own presentation?
Yeah.
Okay. No problem. I'm going to share my screen. Excuse me. Just a second. And that should be.
It's perfectly good, Mr. Desmet.
Okay, so as you can see, we have here the local storage.
Just a question, can you pass on to the presentation mode, please? This is the slideshow.
I'm gonna try again.
If you want, we can share your slides.
Okay, and is this better on this way?
Yeah, it's good. Thank you.
Okay, so if you can see, we speak here about local storage, and I put it the local into quotes since what's the definition of local? Local, I'm gonna take my laser pointer too, that's more easy. Local is not just that local. Local can be at household level. Local also can be at a city level or even at the country level. The question is how local is local and what do I mean with a local storage? I don't going to speak you about storage on itself, but rather the need for storage. And how can we approach solutions for having a good storage system? And finally, I'm going to draw some possibilities for using storage in the nutshell time that is provided for my presentation. Okay, first of all, we have a basic problem. And what's the basic problem? As you can see here on the right hand side of the slides, that's we have a quite big variation in consumption profiles, and that has to be delivered by the different power supply systems who are nuclear, who gives the base loads, yeah, and biomass and waste and other energy forms. But in the end of the story, the renewable energy sources have to provide or have to try to follow together with the small power supply sources the needed energy. And as you can see on the left hand side of my slide, the variation of the wind production over a year varies quite fast and differs a lot, but even the sun production is much higher in the variation, and one of the drawbacks of the sun is hardly between the 6 and the 8 up to 10 hours a day that we have sunlight, and it's not the same for every day. So that gives our some challenges. And what are the challenges? We have to control the balance between production and distribution of energy, and it's shown here on the right hand side of the slide, excuse me. We have the demand of the industry, the households, the companies, the service centers, and so on. And at the left side of the balance, we have the supply system of the traditional power plants, who can create and deliver a fixed power, and at the other hand, the variation of power due to renewable sources, which means we have to balance both, and that has to be kept in balance during the whole day long. So we can compare that with the traffic control. Power lines are just the same as traffic control, as the roads, who have to transport all power or all cars. So that means that we have possibly an overload on the grid, or we have traffic jams in our traffic system. So, and it's always a temporary phenomenon, which means that we have to control that on temporary basis. And for power regulation and control, that's needed that we do it in real time. Real time, that means that every second the power demand and the power delivery has to be the same. And as we look at our impact of our energy production, we have different, now I show you the production sites of Belgium for last years. If you look at the power production, we have the standard power sources, such as natural gases and nuclear, but maybe more important is the renewable energy sources. And there you see that you have three big groups of renewable energy sources, such as the solar power, the wind power onshore, and the wind power offshore. And there you see that utilization factor is somewhere between the 10, 20 and 40%, depending on solar onshore or offshore wind, which means that the solar production, the total produced energy of solar, for instance, can be compared with the full continue power delivery of 10% of the year, and for the rest, nothing. Analog for onshore and offshore. So if you look at the installed power, for instance, the nuclear energy in Belgium, the installed power is 24% of the total installed power in Belgium. However, it delivers 64% of all consumed energy over the year, while photovoltaic installations are almost 20% of installed power, of the total installed power of Belgium, and delivers only a 4% of the energy, which means that if we want to increase the consumption of energy due to renewable energy sources, that we need some solutions, such as there are storage. And in order to give you a better view about that, let's have a look at the production of energy of sun and wind. That are the figures of Germany in 1919. So if you look at the production of the wind over the year, then you see that the total production over the whole year is 100%, and 18% of the total production is delivered in almost 50% of the year. Yeah, while for sun, that 80% of the total produced energy by sun is delivered in 20% of the year, which means that respectively for wind, over 50% of the year, we only have 20% of the installed energy or capacity of the wind turbines, while for the sun production, we have 75% of the year almost no energy anymore to deliver to the loads, which means that in case of no sun production or no wind production, we'll have a kind of a blackout, what the German people call the Dunkelflaute. And then we have a problem with the delivery of energy in our country. However, we have to take care with respect to the power produced by a renewable energy source and the energy produced by a renewable energy source. And therefore we need a new parameter, namely the parameter time. And the parameter time is very important here. If you look, for instance, or the same figures of Germany in 2019, the installed capacity is 50 gigawatts. If you look over the 6-hour average value, we have an installed power of 50 gigawatts, but it only can be used 0 time of the year. And with the respect of a 6 hours average value, we only have 5.6 gigawatt of power who is available during 75% of the year. However, the higher the average factor that we take from 24 hours, it becomes 9 gigawatts. Until 2-week average values, it becomes 12 gigawatt. So we think in an average value, we can provide 12 gigawatts over 70%, 75% of the year. But that's not true if you look in terms of 6-hour values. And if you should look in even faster terms, then you should see that it's even less than the 5.6 gigawatts. So we need to have something as a solution like storage. And in order to have our storage, we need to dimension our storage. But the main problem is, as you can see here, this is, for instance, my yearly sun production, and I want to use the complete energy produced by the sun over a year, which means that I need this average over a year as storage for my renewable energy of the sun. However, if I look at the use of the energy, on day basis, then I see that I only have a few days that I need the maximum storage capacity, while the lowest storage value that I need in order to do is hardly half a year. So that means that I have to install a lot of storage systems in order to provide my total energy, but I only will use it a few moments of the year, and becomes even worse if you look on the time on a 10-minute base. If you look on a 10-minute base, then you see the need of the storage over the whole year. And then you see that sometimes you need very much storage, but 5 or 10 minutes later, you don't need anymore. And what's one of the reasons? One of the reasons is that the yield of the sun is not a constant value, but it can vary quite fast, even very fast. I took here a detail of a one-day production, and then you see that the yield of the sun varies on 1 minute base very fast. That's the reason why we need such a fast storage variations. As a conclusion for that, it means that we have to look for our storage what we really need. So we need a combination of energy and power. Yeah, energy and power in terms of how much energy do I need and how much power do I need on that moment, which means how long, on which time frame do I want to have my storage, and how fast, what are the variations in both production and consumption of energy, should I store how much energy. So we have 3 questions to ask, and this question can be asked by looking at the power of the storage system, how much power can my storage system deliver, or how much energy can my system deliver, or in combination, how much power and how much energy can my system deliver. And there you see a quite big gap between both of them. You have here the group of high duration storage, that's energy access, and here you have the group of high power storage, that's very short time but a very high power. So in reality, we need something as a high energy storage and a high power storage. And that we call hybrid storage. So we have to combine both in hybrid storage, a high power storage and at the same time a high energy storage. And that we have to calculate in our systems. And that's quite difficult. And I take here the example of an energy installation. And here you see the yearly production over of this industrial plant over a year with a gap in power needs. That's during the yearly holidays. But for the rest of the year, you have quite big variations. And we can look at this consumption profile over a whole year in hour on hour base over the whole year, which means that we have to combine this consumption profile with, for instance, a renewable energy profile as for sun, which means that we have to combine both consumption and production in order to have a good solution. And that's not that simple. And therefore, in order to help people, we provided a new European project, who is called STEPS. It's a storage of energy and power systems in the northwest of Europe. And it's based on the situation that in the last decades, there was a massive growth of distributed power production of renewable energy sources. And we want to create storage. And in order to have a good solution between the renewable energy sources and the storage, in order to maximize the use of the renewable energy, then we have to provide and to help companies who are willing to invest in new technologies and new solutions. But we have a lack, we have a problem. There's a limited access to the possible test beds in order to test new situations and new solutions. Therefore, the main goal of the project is try to create a regional energy regulation and legislation for all different partners into the project. And the second point is try to increase the engagement with actual end users in order to provide the end users new solutions and to invest in new solutions in order to help provide new energy storage systems. And in a final point, try to connect the SMEs with suitable end user solutions. So in order to do that, we developed also a business support program with two different vouchers, a voucher 1 scheme and a voucher 2 scheme. And the first voucher scheme is a voucher scheme who is helping to enhance the product and the tailoring of the new solutions for the industry, while the second voucher is the testing and the demonstration of new technologies. So we provide within our project test beds in order to help SMEs with storage solutions for new solutions of the future. So that was in a nutshell my presentation.
Thank you, Mr. Desmond. I have an interesting remark regarding the presentation from Bertrand Guillot, who actually even I wanted to know if the energy consumptions or the electrical load you have considered takes into account the mobility sector and the heating sector, or and the provisions or the estimations for the upcoming years, or not?
No, that's just looked in terms of let's say fixed storage, not mobile storage. But on the other hand, you can combine it with mobile storage, since if you use the mobile storage, it has to be stand still on a certain location in order to charge or discharge. So, and if you make a good organization of mobile solutions, such as vehicle to grid applications, you also could use that for helping in grid stability or in providing energy to the companies.
Okay, because according to him, he can't really agree with your calculation methods, because he thinks that the renewables will also serve these heating loads and also the mobility load in the coming years. and these amount of capacity and the amount of capacity needed will be way more than 100% of the actual electric load.
That's not completely correct, since there's a big difference between power and energy. If you look, for instance, in the fourth slide that I presented, I gave you the utilization factor of the installed capacity. And if you compare power with energy, we have still a lack of 60% that we can provide energy to storage systems over the year. Yeah, but we will not cover all transportation with the electrical power who is installed. That's not possible. That's true, but we still have some margin for the coming 10 years, I think.
Okay. Well, thank you. Thanks a lot for your presentation, Mr. Des. Now I would like to pass on the floor just a second to Mr. Jean Grévillier. Just a second, I would like to introduce him first. Just a second. Mr. Grévillier from Pôle Énergie Hauts-de-France will now present a list of energy storage operations which are already functional or in development in France. Just a second, I think my presentation was cut short. He works closely with the companies and territorial administration for energy transition consulting in areas of engineering, studies, and innovation. So he's a director of the company, and I think he'll give us a great overview of the projects being undertaken. So the floor is yours, Mr. Grévillier. You can start presenting your slide.
Yes, thank you very much. So I share my presentation. If I can do it, let me just, yes, I think. So normally you can see my presentation, right? So thank you very much.
No, not for the time being, Mr. Grévillier. Yeah, now we can see it.
You can see, okay. So thank you for inviting me. So I will not present our cluster in Hauts-de-France. You told it. So my purpose is to present you an overview of different storage solution in France. So concerning the different energy, so we will speak about heat, electricity, gas, and of course the link between them with power to gas. So of course concerning heat, the very simple way to store energy is to have a capacity, a big volume of hot water. So it's.
Excuse me, Jean. Could you go to the presentation modus, please?
I want, but I guess we cannot. After I cannot pass different pages. That's a problem. Is it better now? Can you see the whole page?
Not for the time being.
And it's going. So, can you see?
No, I think it hasn't changed for the time being. So
I come back to the.
Yeah, you can. I think it's better if you can come back.
I'm sorry. Yes. So heat water. So you can see that with district networks in some countries, not so much, not in France. Here you have an example with Austria. But what we can see in France is storage capacity linked to a cogeneration unit producing electricity for the network, and the heat is stored in big volume and will serve greenhouses, which is behind the big capacity you can see here. It's a way to use the heat produced by the cogeneration unit. So it's an example we have in Hauts-de-France region, this kind of storage, very simple. Another way is to use geological storage in two different ways. Either you send heat
Mr. Gavin,
underground.
we can't see your other slides. Are you still on the stockage hydraulique?
Yes, yes. But
Okay.
no, I go to the next page, but you know there is always a time, a lack of time. So I think it will appear somewhen.
Okay.
But I can't do nothing because or you take the lead of
yeah, I can. If you want, I can share your slides and then.
Yes, with pleasure.
Okay.
Yes, so I stop sharing.
Yeah, you can stop the sharing. You can tell me when I have to switch the slides.
Yes, I will.
Thank you.
Of course. Sorry for this.
No, that's not an issue.
Webinar, as always, is kind of.
Can everyone see the slide on full screen?
But it's not the right one. This is a mail presentation. It's not mine.
Just wait. That's bizarre. Oh. I'm really sorry.
No, it's.
Is this the right one? Right? You can see.
Yes, you got it. Yes. So go ahead. We are on page, I guess, 4.
Okay. Yeah.
Yes. So that's it. So you can use this kind of loop and system on both ways. Either you are using the natural heat of the ground underground, which can be between 50 degrees to 200 degrees, depending where you are. Especially in the region, we have a lot of geothermal possibilities. Or you can use the underground to store thermal energy. But when we say thermal, it can be cold and hot and warm energy in cavities under the ground. And so with that, you can use the system as a heating system or as a cooling system. And Weishaupt, of course, which is a German company involved, of course, in France too, is quite a good partner for this kind of solution. Other solution is quite next slide, please, which is quite new. It's the capacity to store heat water with a chemical solution, and the chemical solution we transform a substance in another one. So on next slide, please, you have the example of the company Water Horizon, which is a startup. You see, you have the same problem as me. Huh? You cannot go to the next page.
It's okay, right?
Page 5, please.
The stockage chimique.
Yes.
Okay, that's good.
Yes. Page 5. Yeah. You can go ahead.
Okay.
So with this solution of Water Horizon, the heat transform a substance in a liquid in a solid form. And so you have the great advantage with that to have a storage of heat without loss. So you can store it for years without problem. So you can store something like 10 megawatt thermic in a container, and it can be used for instance when you are at the end of district heating system and you have some clients to provide with heat, but some distance from that. And instead of building a new pipe, which is quite expensive, this solution can be a way to store energy and to provide this energy to the end consumers. This solution has been labelized by EDF Pulse, which is which is how to say that in English? It's a concours. I don't know the word in English. Concours, I think, or something like that.
It's competition.
Competition. Yes, for startup. This company is based in Toulouse, and we will have a great development, I think, in the next year. Another solution you have on the next page is quite the same, but more developed for high temperature. The advantage of water solution is to work with quite low temperature at from 50 degrees. Here you need quite high temperature, but it's quite interesting, and they have been labelized by ArcelorMittal, which is a producer of steel all over the world. So this is some solution about heat. Now I come to gas on the next slide, just to tell us with this map, just to remind you that the networks, the pipes, are a way to concentrate energy, are a way to store energy, because you can play with the pressure of gas in the network. If you take only GRT Gas, which is a transport company, not distribution, but transport company, they have 32,000 kilometers, 26 stations of compression stations, and you can play with the speed of the gas running inside the pipes, and of course with the pressure, and with that you can store, you can have a certain storage capacity in the network. But you have also other solution. Next page. It's of course LNG, the liquefied gas, which is stored at minus 160 degrees, with different capacity of storage. For instance, if you take the down picture, you have here the LNG terminal in Dunkirk with 3 tanks of each one make 190,000 cubic meters of energy. But of course here, the idea is to store energy, but also to play with the tariff, with the gas spot prices all over the world, because when the ship are going out, for instance Japan, or I don't know, Singapore, or where the place they are loading the gas, they don't know exactly where they are going, because it's depending not of the decision where they want to go, but the decision is where the price is better. So the LNG terminal is a player not only for technical storage, but also for price and market decision. So next slide. Another solution, of course, it's concern geological storage. So we have a company in France which is a subsidiary of the NG Group, StorNG, and they have 23 places in France for gas storage. You can store methane, you can store hydrogen, you can store CO2. With different way, which is either you are using empty previous place where you had gas or oil, or you can use aquifer. The idea with aquifer is the gas takes the place of water, so you have to use pressure to send the gas and to pull out the water in porous and permeable rocks. And you can use also salt cavities, where you will take off with water the rock salt, and the advantage of salt is it's impermeable, so you can store the gas inside a kind of how to say that, a bulle, I don't know the name in English, a cavity of where you took over off the salt. So we have 12 aquifers in France, 6 salt cavities, 6 sites, and we have 78 cavities. And you can also have 4 cavities which are artificially made by how to say that, as they are built under the ground with a cover or without a cover. So we have four such cavities in France. So 23 sites managed by Storengy in France. Next slide. Then we come to electricity. We should start with that and remind that simply heat accumulator in each house, in each apartment, is a kind of storage because you are using low tariff during the night to heat up the water, and using during the day at the morning or evening for shower and so on. So simply heat accumulator in your apartment is a storage capacity because it's using nuclear energy, for instance, in France during the night, which is cheaper, and during the day you can avoid to use too much electricity and let electricity for other use. If you take the electrical network in France, which through which pass roughly 500 terawatt-hour of electricity, according to RTE is a transport company of electricity in France, there is no need of big storage capacity until 235. So with the development of green energy, of renewable energy, their estimation is they can manage the installation of this green energy without big storage capacity. So that's a point that had been made some years ago, and it's a reference for everybody now. Next slide, please. Of course, we have to take into account an usual way of storage, which is a storage of energy and power system. We spoke about that just before, so I will not speak too much about that. We have 6 of them in France with a capacity of 4.9 gigawatts for the turbine. That means for energy production, and 4.2 if we take the other way for pumping water to the upper level. And of course there is a notion of efficiency, of yield. So if you need to produce 1 megawatt-hour, you should consume 1.25 megawatt-hour in average, with pumping the water from the lower part to the upper part of the system. So of course we need to deal with the tariff, to the difference of tariffs to find economics on this issue. Next slide. Another way more recent is storage with battery. So here we have an example, the Mobility House, which is a German company, but they are installing in France a storage area. One container contains batteries, but it's second-hand batteries from cars. So they have an agreement with Renault, and they are using second-hand batteries, and they can, in one container, they can provide 1.3 megawatts. They can store 1.3 megawatts. And Renault will install, next slide, please. Renault will install such capacity of storage in their plant in Douai, so it's also in Hauts-de-France. We have also a big project with Total. They will install near Dunkerque 25 megawatt-hour, 25 megawatts, not hour, facilities with battery lithium-ion. It's a project of 15 million euro, and it is an answer to a tender launched by RTE RTE, so the transport electricity transport company, and so it's a way to store energy and to regulate, to balance the production and the demand of electricity on the network. Next slide. So now we come to this power to gas. Of course, if we have too much renewable energy, especially electricity, we can store it, converting it in hydrogen through electrolyze. So according to RTE, in 2035, we have a potential volume of production of hydrogen of 30 terawatt-hour. So the question is, of course, there is also efficiency of this conversion, and we know that electrolysis is producing also heat. So it's orange part of the picture you have. So the question is what we can do with this heat, and can we recover it? Can we have solution to recover this heat? Other next slide. Of course, hydrogen, you can store it. We have some example in France. So two projects here, one in Aquitaine, another one in Manosque. Manosque is Provence, in Provence. So Provence, it's a huge project because they plan to do before 2027, 900 megawatts of photovoltaic production. And they are saying that 50% can be converted in hydrogen and can be stored in salt cavities in Manosque. So if we take 100 cavities of 500,000 cubic meter at 200 bars, we can store the whole production of renewable energy in France in these cavities. So it's a huge amount, and this is the average of this geological storage, is to store a huge capacity of energy. Next slide, it's the reminder about what is power to gas. So coming from renewable electricity, then electrolysis of water, possibility to send the hydrogen to network, or to also possibility to use this hydrogen to produce synthetic gas, methane, which with, of course, the addition of CO2. So this is the idea of the project Jupiter 1000 in Fos-sur-Mer, so in south of France, not far from Marseille, where they are studying all these different steps of power to gas for a project globally of 1 megawatt electrical, with injection of hydrogen 200 cubic meter per hour, production of methane, of synthetic methane, 25 cubic meter, using, of course, CO2 from another industrial supplier. So it's waste CO2, of course, from industrial not far from the site. So the idea of this project is to measure all the different parameters and to come to an industrial vision of power to gas for the country. Next slide. Another project of power to gas. So we come back to Dunkirk, so the upper part of France, which is the first project of massive production of hydrogen. So it's a company H2V, 59, because 59 is the number of the North Department in France, and they will produce 28,000 tons of hydrogen per year, using, of course, green electricity. So investment of 200 to 250 million euro, creating something like 70 direct place for workers and 100 indirect. So it's a huge project. It's a first project, and they have another project similar in the port of Le Havre, so in Normandy. Of course, the idea is to install such capacity, such facilities at the entrance, at the inlet of network of gas network coming from Norway. So in France, we are receiving the Norway gas in Dunkirk. And so, of course, H2V is installing its capacity near this this pipe, with the idea to introduce hydrogen to in the network with a small percentage, but of course, as the volume are huge, the volume of hydrogen will be huge too. So next slide. I think it's the last one.
Yeah,
so another project.
Sorry, Mr. Gravillier, I think we are also running out of time. So yeah.
Okay. So, but you will read it after. It's not so. It's interesting here to see the consequences of one project. Well, for the dwellers, for the habitation, but I think grid is quite known project now. Okay. Thank you very much.
Thank you, Mr. Gravillier. And now I think I'll pass on to our first expert of the day, which is Mr. Pierre Guello from Enercop de France. So just a second, I'll just pass on to his presentation. Sorry. So Pierre works for Enercop, a renewable energy producer with cooperative structure focusing on solar PV, wind, and micro hydel, and also cogeneration. So he'll be explaining us how the energy supply and demand is modeled by the producers, which will give us some perspective about the need of energy storage. So I think
if you can share the slide, Apan.
I think yeah, Pierre. Jörg, can you? Yeah, that's good.
So hello everybody. So Enercop is a renewable electricity provider and has to manage production and demand balance. So here we will see our day-ahead load forecast. Mainly, this is the mainly part of the presentation. The principles are the same for production forecast, only the input data are different. And then we will see our limiting factors on accuracy, and then the data that are needed for production forecasts. You can put next slide, Ampan or Jörg. So here we have a day load forecast for one site. In blue, the power load that we have seen, and the forecast we have done. That it is just for one site, but we can do it for all the sites we are of our consumers, and then the prediction is better than only for one site. Next slide.
Jörg, can you change the slide, please?
So the predict function that we use is runs daily to have a 1 hour time step consumption prediction for the next 7 days. And the precision of this function is about 2-3%. Next slide. This prediction function is trained every week to adapt it on the current consumption trends. It was very useful during the lockdown. Next slide. So the key aspects of this prediction functions is the quality of data that we need to have good precision on this prediction function. So we will see next on the next slide the different input data that we need. So first we need historical data. So each consumers on the grid is assigned to a profile that is for all the providers. There is, for example, residential with day presence or without day presence, office profile, and small professional profiles. For large industries, we don't use a profile. We use the data itself of the industry and the historical data of this large consumer. Next slide. Then we need the calendar data because on the grid the consumption of electricity is different if there is holidays or weekdays, if there are school holidays, or if it is summer holidays, or there is a national holiday or a lockdown, for example, last year. Next slide. Another point very important for this input data is our portfolio. Is to well known the number of our customers and the power subscription, that is the KVA per profile. This data is varying every day. We have new consumers or some consumers that go out, and that is a very it's not so easy to get the precise number of our consumers, because if a consumer can come to our become one of our consumer, there is some administration things to do before it comes really a consumer, and then it's not so easy to get this information, the precise date that the consumer is in our périmètre in French. I don't know the English word that for. Next slide is whether so that's quite important to have the load forecast is the weather model, mainly the temperature. So we have a temperature for whole France. It is based on a weighted average depending on the population of the different cities. And we use two forecasts models from Météo France and the American one, GTS. Next slide. Then we use the TSO data. It is the transmission system operator. In France, is named RTE. It is also the transport operator for France, and it so also the transmission system operator. It provides national load forecasts. We use it partly to train our prediction algorithm. Next slide. So the function used to have this prediction as is trained, like I said before, every week, and is based on 10 different models, mathematical models. 5 models are trained with the TSO data from RTE, and 5 models without this TSO data to have a good accuracy on the prevision. So what we achieved today is to mainly 2% error. Sometimes it's more, but mainly it is 2% error every day. Next slide. So as said, we have what is difficult to get accuracy is the quality of the data. So our main problem, as said, is day-ahead customer contract data to really know who are at this precise date our consumers. And to get the data for large enterprises that comes in our that becomes our consumers, because they have as they use a lot of electricity, it's quite important to have the data before they become consumers. Next slide. So for the production forecast, so as said, it's based on the same principles. The data are different. For the load forecast, we use mainly it is temperature from the weather. Here, from the weather, for the production forecast, we have to have forecast for solar, for wind, and for hydro data. Yeah, and the other point is to have the availability of the different production plant, and also the maintenance plan for all this plant for all this production plant. So next slide. My presentation is ended.
Thank you, Pierre, for this. Actually, it was quite a technical presentation.
Yes.
Yeah. So I just have a question for you, Pierre. How do you think the load previsions can help in the programming of energy storage?
This provision, I think, is the first step that we have to do because it is easier to make prediction than storage. Prediction is, as electricity is quite difficult to be stored. It's quite important to have a good prediction between and a good balance between consumption and production, and then we can use storage when we don't need the electrical production. Okay. At a precise date, and then we can say at this moment we don't need this production, so you can store it, and at other point at sometimes we need more electricity that is produced than to take it from the storage. But the main challenge is to have a good prediction.
Okay, thank you, Pierre. Now, for the next presenter, we have Mr. Nicolas Huguel from Vent du Nord, a company in rapid growth, especially in the north of France. As you can see, it's Vent du Nord, so it's Wind of North in English. So with quite a few installations over here, so he'll be talking to us about the link between renewable electricity production and energy production as a whole, which was explained by the speakers before him, and the link with the storage and the production of green hydrogen. So the floor is yours, Mr. Huguel.
Okay, thank you. Hello everyone. Thank you, Arfan, for your presentation. I tried to share my screen. Okay. Is it okay for you?
Yeah. Can you go into the presentation mode, please?
Like this?
Yeah.
Oh, okay, perfect. So, thanks again. Yeah, it's okay.
Sorry, no, I think we are still seeing the main screen. Just a second. Do you want me to present your PDF? Maybe. I have your PDF, so if you want, I can share that.
Okay.
Just a second.
I cut my sharing.
Okay. Just a second. Yeah. Can everyone see this?
Yeah. Okay.
Yeah.
Perfect. Thank you. Thanks again for your invitation, and so I'm very happy to be with you today. So I just want to maybe to speak with you just a little hydrogen project. It's not so big like a big project John can show you soon, but it's just like a demonstrator. We start the few years in VDN. So just before you can pass and make next slide, I just want to introduce the VDN company. VDN company is an engineering office in France. This company was created in 2013. VDN is a subsidiary of a company from German group whose name is Loscon. Loscon is based close to Berlin, and so during from 2013 we try to develop renewable energy with our first activity was wind turbines, and now we have 69 megawatts in operated, around more than 120 megawatts in construction, and more than 600 megawatts in development. We have 3 agencies in France. As you can see, the most activity we can have is on the north of France. We call Vent du Nord, so that's why we have more activities in the north. But now we have also more and more activity in the west and also in the south, because we continue to develop wind turbines, and also we start to develop PV solar, PV energy in the beginning of 2019. So that's why now we have 145 megawatts in development for PV, and we start also hydrogen in 2015. Why we start hydrogen? Because we want we wanted to show what renewable energy can give. It give more than the simply produce green energy. Hydrogen is very important for local regulation. Is very important also to make a link with we will see in my presentation with renewable energy. We have also a sustainable approach because it's as a green in green sector energy. So we will see it's very we can have many capacities and many utilities for hydrogen. Just for finish with VDN, VDN is also with link with many associations and also clusters because we try to be close to the local people when we develop some project, wind project, also PV project, and of course hydrogen project. And now we have 5 big projects in development for hydrogen in the industry, on methanation, and also for mobility. Next slide, please. Okay, so I just would like to show you this slide. I'm not going to linger for long on this slide, but I just want to explain in few words the process. We have a renewable energy, wind and PV, and we transform it in hydrogen, in gas. I think you all that experience in high school. You immerse the electrode in water, and with the electric current, you see some bubbles appear in the electrodes. These bubbles are hydrogen and oxygen. We will do exactly the same, but in bigger. So we can transform the electricity, the green electricity, of course, and hydrogen. We can storage this gas, and we can use this gas for industry, for mobility, and also for it. And this is what we said, Jean said soon also. So what I say is it's wonderful energy carrier with many uses. We can use like I said for industry, mobility, etc. And we can see also we can reduce CO2 with methanation. So we get CO2. We will link with H2. And we produce CH4. So it's very interesting, but it's not a topic for today but it's very interesting to reduce with methanation the capacity of CO2. So now I propose to you to make a focus on mobility, about our demonstrator. So we can change the slide, please. Yes. So our project is a little project. This project began in 2015 with a wind park project. We began to discuss with mayors, we discussed with people inside the village, and we try to make the difference. We wanted to set ourselves above from other wind energy, the project developers in the sector, with an innovative and useful measure for the local people. So we have a wind park project with 6 turbines. We have 18 megawatts on this project, and we propose to the mayor, to the village, to install the vehicles, hydrogen vehicles, and a little station will produce hydrogen with and use these vehicles totally free for people and totally green. And this project was very important for mayor, very important also for people, because for the first time they realized what renewable energy can give, and we want to show that we can have direct interest in the setting up of a wind farm. Sorry, so it was the first time we did it, and we have an acceptation. We had an acceptation, a wonderful acceptation about wind park, and we continue in this way during all the development. So so now the wind park project is in the end of the development. We're going to begin the construction in the end of this year, and we try also to have this measure. So we are working for the moment to have vehicles, and vehicles is very difficult because we don't have so much offers about construction for cars. We just have two constructors. We have Hyundai and also Toyota for the moment for a globally totally hydrogen car. But if you want to make just to compare the electric car and the hydrogen car, we want to take just only hydrogen car for rural environment, because rural environment is very difficult, and what I say is the mobility is life on the rural environment. So if you want to compare, for example, an electric car, we can refuel in 2 or 3 hours. A hydrogen car, we refuel in 5 minutes. The autonomy is around 200 or 300 kilometers for electric car, and for hydrogen car is around 600 or 700 kilometers. So my pleasure to say is not the person who puts himself at the service for technology, but it's the technology that is at the service of the person. That is very, very important with the hydrogen car. So it's very big. It's a little project, but it's very big importance for people, local people, and also for mayor, because now this measure isn't built for actually, but the mayor is already on the next step. He wants to buy a bus. He wants to buy many vehicles also. So that's why it's maybe a start for the future. But for the moment, we try to just to build the station and vehicles. So, and also, yes, for we have been laureate also for Hydrogeny for this project in 2019. So it was in the beginning how we have to build this major this project. I think we can make the next slide. Thank you. We propose to when we discuss about with people in village, we say, okay, we have electric car and we have also hydrogen car. We propose hydrogen car because, like I said, rural environment is very difficult, and you need every day, every time your car. Mobility is life. So with a hydrogen car, you can make a little trip, but you can also make a big trip. You can go on Brussels, you can go on Lille, you can go everywhere around the village. Her name is Tupini. You can go also on a little trip and to make shopping close to the village, to go on a post, etc., etc. So this is the I wanted to show that in this slide because it's what we propose to people in village. And like I said, the mobility is very important for people. So it was very important to show them what we can use with the cars. And on the last slide, we began in the beginning in 2015 when we proposed these measures. We organized a little survey to to set up the measure. And that's why we decide to finance 2 cars, because sometimes people ask us why we don't finance just 1 car. Or, we organize this little survey, and what is very interesting is people already have a car, but they need a second car to make shopping to close to village, like we show. Because usually the first car is used for work. So many guys, many people in the village needs a second car, and especially a green car and a free car. So that's why it was very interesting and very important to make a survey in the beginning to see exactly what people want, what people need, and we can now to set up the measure. So we hope it's a start. We hope it's a beginning to develop hydrogen, because we can build a station in this village, and we try in VDN to have exactly the same measure for our wind park project and also PV projects. We organize, we discuss with mayors, we discuss with people each time to evaluate if it's possible, if they want or they don't want to have it. But we discuss with them if it's possible to propose this measure for mobility, for green mobility, and to have a link between renewable energy each time, maybe with wind or for solar, and to have this link to produce and provide hydrogen. And I think it's finished. Thank you. We cannot hear you, Apan.
Sorry. Yeah, it was nice having a presentation, and I think Pierre has a question. Pierre, can you do you want to ask some question?
Yes, I wanted to know how much hydrogen produced the station every day.
Every day we have 10 kilogram. We can stock. We can store it, make a storage for 10 kilogram, and for each car the capacity of the tank is around 5 or 6 kilogram. So that's why it was very important for us to have a totally hydrogen car, because it exists some hybrid car with electric and hydrogen. For example, we have the Renault Kangoo. The Renault Kangoo is a hybrid car, and it's an extender with hydrogen. And this type of a vehicle, it's difficult because you need to charge again your car by electricity, and it was very difficult to accept about people to charge during 2 or 3 hours. So that's why we want especially to have completely hydrogen car, and as you can see, we can go everywhere. So that's why we decide to give the cars to the community, and keep the station, and we organize all things for the station, and for the future the commune organize the rent for cars. So maybe, like I said, maybe in few months, maybe in next years, or etc. We can increase the capacity of the station. But for the moment, 10 kilogram is it's okay, is enough.
So there was Mr. Jean-Paul Mousseau, who had asked us a question: what is the place of hydrogen and important e-fuel in the energy storage model? I think we have answered his question through this presentation.
Yes, it's for a previous presentation. This question it's not for this presentation. This question is for a previous one.
I think it was
yeah,
okay. Just before.
So even
but for us, it's a big part.
Yeah. So I have a question, Nicola. What is the average cost of production per kg of hydrogen from renewable energy today? I think this is something which is quite important for at least for collectivities.
For the production price?
Yeah.
Yeah. For this project, we don't win any money. It's just a major link to the wind park. So it's not we lose money for this major. So, but we have also more and more project and hydrogen project, for example, for industry in the east of France, and I can say you for the moment the production price is between 6 and 7.5 euro per kilo, and the big part of this price is the electricity price is around 70%. So that's why it's very first for electricity, but for the moment, yes, it's very complicated to have a good price. The government give some system to have a tariff to make a gap with the real hydrogen price. We have also subventions. We can decrease the price, but yes, for the moment, it's very expensive and very difficult. And when we have a production price between 6 and 7.5, it's complicated. Yes.
Yeah. Well, thank you. I think we'll take a little break to have a coffee, to have a cup of coffee, or have a little walk to circulate some blood in our systems. So I guess we can join within 5 minutes. So at 15:10, I think we can join. We can all join back to this meeting and continue for the second session. Thank you.
Ja, is het.
So, hello everyone, and welcome back to the second session for the Energy Storage Concepts Conference, a networking event for SOLARISE. I hope everyone is a little bit refreshed after a little break. I had some coffee and some water. So, to start with our second session, we have Mr. Rico Denoden from Hokosto, which is a company which works on pre-printed seasonal thermal energy storage, which is compatible also with solar thermal technologies. So I would now like to give the floor to Mr. Denoden to give us some detailed knowledge about his process and this technology.
Okay, thank you, Apan. I'll share my screen.
Yeah, you can share your screen. Very cool. It's fine. Yeah, that's
perfect. Do you see my full screen?
Yeah, it's good. Thank you.
Okay, Hokosto is short for hot cold storage, and I'm president of the French part of the company. To give you a short history of the concept and of the company in the Netherlands, created the idea, was born in 2012, and took them a couple of years to develop the concept. 2016 they applied for a patent and started to develop commercially. In the Netherlands they are very well developing. They have several projects right now, orders up to 30 million, and already reaching towards 20 employees. In 2018, I contacted them because I sold my previous business and was looking for something in the sustainability market. And because I've known them, the founders, for 10 years or more, I agreed to them that I would go to explore the French market, and that has resulted in last year in the creation of Hokosto France, and already included in several commercial trajectories. The challenges and barriers I encountered in the last couple of years are, well, the barriers are the system, the principle is not very high tech. It's based on simple physical principles. So at one point in discussing with an investor, an investment engineer asked me what is so innovative about it, and I told him it's simple physical principles. Sorry, and yeah, so the innovation is combining it. And the second barrier is the unfamiliarity with the subject. The principle is very old. The first project in heating with an underground storage date from 2007. The challenges in France I encountered is the focus is, especially in France, all electric, and also in the Netherlands, but also in France, there's still a lack of regulations for underground storage for heat. And even at the level of ADEME, it doesn't fit in there the way that we do it, and I'm going to present it in the next slide. The way that we do it is not fitting for the existing formats. At one point, a couple of weeks ago, they even suggested to ADEME to change the principle and to go to geothermal probes for storing. And well, that's not what we want to do. The solution in principle is it allows you to disconnect the production and consumption point. And that can be seasonal, what we are talking about right now, but it can also mean for hours or days. It's depending on looking for the energy balance. That's what we are always looking for. What is our cost of storage? It's basically an underground structure, an underground of water, which we excavate, put the structure in, several layers of isolation, and close it. And you can reuse the space as a parking space or as a playground for children. The structure is the point that is patented, and because we were the first in Europe for sure that created an internal bearing structure for basins, for storages at this size. And size, we talk about from 100 cubic meters towards 10,000 cubic meters, all depending on the need and the energy balance that you're searching for. Like I said, it's a patented solar thermal structure, and further no construction required. And you can use it, the temperature we are working with is between 15 and 90 degrees. The end of winter, like the image is showing, at the end of winter it's 15 degrees because all the energy in the storage is used. And then from the production side, you have solar panels who will be heating the storage. And the end of summer, beginning of autumn, it's at the maximum temperature is 90 degrees. It's a very good alternative for all electric heating, because the pricing of electricity will increase enormously, and it gives you the possibility to create a local and decentralized energy system, a local network. What can you use it for? You can use it for residential and school complexes and tertiary buildings, offices and sporting complexes. And for all those three possibilities, solutions, we have already some projects done in the Netherlands. Another possibility is data centers combined with eco-districts or villages to deliver them heating of the residual heat from the data centers. And you can provide the data centers with cold, how do you call it? Climatization. One of the biggest advantages is because you look for the energy balance, and you can use our storage, our way of storage, like a peak shaver. You can reduce the power, the necessary power of your heat pumps up to 50%. And for the eco-districts, one of the projects that was elected by the Dutch government to to be the first villages without natural gas, the village Nagelen. They are using our solution, our storage solution and heating solution to create a successful project. There are also possibilities in recovering of heat, and for this client we did it in a way of creating cascade of storages in different temperature levels, and combined with heat pumps, we can provide them with, always looking for the energy balance, like I mentioned, we can provide them with the temperature for their industrial processes. And that can be up to 150 degrees combined with the right heat pump. And at this moment I'm in the commercial process with a tomato grower to provide him with all the necessary heat, but also cold during summer, to regulate his temperature within his greenhouses. Like I mentioned, the village Nagelen, you can create with our solution, you can create eco-districts, community networks, and we have the project I mentioned, Nagelen. It has almost 500 houses and a couple of utility buildings, and the project phase is now waiting, and I think it will start next month with the execution phase. All the work preparation and engineering is done. And it's a project where they start with the first partial project, have a sort of pilot project, and to learn, not only for us, but mainly for the project group, to learn how it works and to learn how they can, how do you say it, regulate all the finances possible. Well, and principally the value proposition for while using the coastal buffer, it reduces energy costs. At the moment you have installed it, you have free heat all year round, independent of the source. Can be geothermal, can be industry, can be solar panels. We have a good alternative for all electric, because, like I mentioned, it will increase, and some say it will increase in a couple of the next 10 years with 400%. You have a very strong reduction of carbon emission, and I'm currently working on a project, and the emission is reduced with 80%, and with using our our solution, you can save on the power of the heat pump. And for projects like this, a reasonable return on investment from 11 to 70 years, it's reasonable. And I want to thank you.
Thank you, Rico. Thanks a lot. And I just have a question for Rico, because at Fourmies we are planning to develop an eco district by the year 2025 or 2026. So I just wanted to know if there are some minimum quantity of heating needs required for the system to be economically and technically feasible.
Yeah, we ourselves, we don't speak about minimal heat. We talk about the minimum volume, and minimum volume is 100 cubic meters, and with 100 cubic meters, yeah, you talk about around the 6 megawatt hours of energy.
Okay.
Depending on some parameters. So from there on, it's technical, from energy point of view, feasible, but for a single house which you can provide, it's too costly.
Yeah.
But you can scale up to one of the projects I'm currently working on. It's 10,000 cubic meters of storage. You talk about 9,000 megawatt hours.
Okay.
So
okay.
That's one of the biggest advantages that we have, that we can scale from apartment complexes, 10 apartments. You can make it from energy point of view, but also from financial point of view. We can make it interesting, feasible, up to whole villages like Nagelen. There's no problem at all.
Okay, because I think we'll be having heating needs of about 3,000 megawatt hours per year. So I'm not sure if that will be enough for such system to be feasible. Okay.
No, it's very good. It's very good possible. Shouldn't be a problem.
Okay. My next question is regarding the return on investment, which was projected. It was around 12 years to 17 years. Does that take into account the subsidies?
No, I've especially didn't take them in account because we are still talking with for sure ADEM, because they have told me, it's a very interesting storage, a very interesting concept. We will subsidize it to a certain level, but it's never subsidized the solution itself, but it's always the project. So because you have several ways to look at things, the return on investment, it's without taking into account the subsidies.
Okay, that makes it a bit more interesting, because if it's included in Fonds Chaleur of ADEM, you can have a subsidy for about 45 to 50% for industrial usage and up to 70% for public domain. So that makes it very interesting.
And the other levels for the project, the tomato grower I just mentioned, we are talking with the regional subsidy funds, and they are very eager to help us, to help the client to implement our system. And we have subsidies with the CEE, CEE subsidies. So besides ADEM and heat funds, there are other possibilities.
Okay, thank you, Rico.
You're welcome.
My next presenter and our last expert for the day will be Mr. Rémi Bastien. Just a second, I'll just get to his presentation. Just I think, yeah. So Remy is working is the co-founder and CEO of InnoGrid. So he works in spearheading the development of collective auto consumption through doing consulting work for industries, and also for the public sector, giving courses and teachings, and also designing energy management software and doing some innovations. This technology is not exactly an energy storage technology, but an alternative to it, which, if implemented at large scale, could actually change the horizon of energy transition. I think so. The floor is yours, Rémi.
Thank you. Hi everyone. So thank you for the introduction. I'm Rémi Bastien, CEO and co-founder of Energrid. And as I said before, I will talk to you about collective self-consumption as an alternative to storage of electricity. First, a little bit about Energrid. So our job is to facilitate collective self-consumption everywhere in France and as of today and tomorrow in Europe. So our job is to inform the future project leaders, then to support the implementation as working with the design office, and we have developed a software to manage and optimize the operation of collective self-consumption. As of today, we have worked on almost 30 projects, almost everywhere in France, and we have already equipped 15 projects in operation with our web platform for them to follow and to manage their collective self-consumption. Our operations are mainly with the PV production and mostly led by local authority and social landlord. A little bit of context about self-consumption in France with the French regulatory framework. So on one part, we have individual self-consumption where one consumer produces the electricity that he uses. And we have collective self-consumption where electricity is supplied between one or more producer and one or more final consumer, all connected within a legal entity. A little bit more in detail, we actually have two models of collective self-consumption in France. We have the basic one where it takes place on the same building. You can be on low voltage or high voltage network, it doesn't matter, and you don't have any power limitation. And then you have the extended collective self-consumption, the one that we think about first when we are talking about collective self-consumption, with several buildings, all within 2 kilometers, 2 kilometer circle area. So it's like a big neighborhood. Everybody has to be so far connected to the low voltage network, producer and consumer. Soon it will change in France. We will be able to play on the high voltage network as well. And you have a maximum, you have a power limitation, and you can have maximum 3 megawatts as a production source. One thing which is very important to know about self-consumption in France is that there is a direct link between individual and collective self-consumption. When you are making individual self-consumption, you produce your own electricity, and you can have some surplus that you will inject to the grid. And actually, to do collective self-consumption, you can first begin by individual self-consumption, and the surplus will feed the collective self-consumption. So first, as a producer, I will produce for myself, and then instead of selling my surplus to the grid, I will share it directly with the other consumer of the community. So now, why do we see collective self-consumption as an alternative to storage? So let's take an example, a simple example of one house with PV production doing individual self-consumption. So in blue you have the consumption along the hour of the day, and in orange you will have your PV production. So usually what we see is that it's very difficult to have power generation and self-consumption exactly in the same times and in the same amount. For example, here on this example of one day, we have a self-consumption rate of 64%. It's not bad, but of course we can do better. One solution would be to put a battery to store the electricity that you don't consume at the exact moment where it's produced, and to consume this energy at the other hour of the day. But the other possibility is to add more consumption by making a collective self-consumption. For example, here my house, which is producer, will make a collective self-consumption with, for example, 4 other buildings. Each other building has its own consumption curves along the day, and as a result, the house will first consume his own electricity and then will share its surplus with the 4 other buildings. Because you accumulate all the consumption, you have now a self-consumption rate which is much higher because you don't lose the electricity that it's your surplus, but you will share it with the other building. So that means you have more capacity self-consumption capacity to put against your production capacity. Now let's say how to decide between storage and between self-consumption, collective self-consumption. We'll have to take a look at the value of the local production. In France, when you do collective self-consumption, the value of local electricity is not the same when you are making individual self-consumption or collective self-consumption. When the energy that you self-consume directly on the production side, you don't use the national grid, so you can save, let's say, directly 50 cents as a kilowatt hours. However, once you go within the collective self-consumption circle, you use the network, and because you use the network, you have to pay a fee, a tariff, and taxes to be able to use this network. So that means the collective self-consumer will not win 15 cents as a producer, but they will win, or they will gain only 6. So that's where you have to find the balance between is it more interesting on economical point of view to do this one? Are you happy with this economical model, or is it more interesting for you to put a battery directly on your production side to be able to that all your production is valued 15 cents? So that's a question that you have to ask yourself when you decide between storage and collective self-consumption. Here I make you some explanation about the value of the local production. As I said, when you do the individual self-consumption, you will save all the value of your kilowatt hour on your bill. That means you don't pay the electricity, you don't pay the network access tariff, and you don't pay the taxes. However, when you are in a collective self-consumption, you save only the electricity, the electron. The network access tariff and the taxes are still applicable to you. So that's why for the moment the economical balance is a little bit tricky. But actually, from our experience on the field, considering the low price of electricity in France, we have found that it's more interesting to do collective self-consumption instead of installing battery storage on the economical point of view. Thank you for your attention, and I'm ready to answer your question.
Thank you, Remy. It was quite interesting. It's actually thanks to InnoGrid and one of the courses we followed that we were quite interested in doing the collective self-consumption at Fourmies. I have just a question is as an alternative, because it's an alternative to physical energy storage, do you think the massification of collective self-consumption is from local production is a real solution for rural and small cities, or should we go towards smart grids or microgrids, because that it requires a lot of investment?
Yeah, exactly. For us, from my point of view, the very good thing of collective self-consumption is you don't have to add any more materials. You don't have to pull cable. You don't have to put your own meter, your own EMS, etc., etc. So it's actually a system which is very, very easy to implement, and you don't have so much. It's like a small smart grid without a lot of capex. So that's very interesting for the small city, which they cannot make big investment. They cannot manage also big and complicated, complex projects. So yes, I think it's a very good solution for small city.
Thank you, Remy. I see that there ain't other questions for you, so thank you for your presentation. So now I'll last of all, I would like to end with some of our experiences, experience of Fourmies and also Métropole Européenne de Lille. So that's Lille in short. So our experience is regarding collective autoconsumption, and Lille's experience is regarding physical energy storage. So for our project, we have in the Interact SOLARISE project, we installed 3 rooftop solar power plants. So one of which was in total reinjection. So whatever we produce, we sell it directly to the grid, and for the other 2, we are doing collective consumption. So for the first one, for all these 3 power plants, we did public funding for our to increase the adoption of solar technology with the help of SOLARISE, because it's financed at about 60% by them and also the Région de France. So for the 2 installations, as Remy explained, the principles of auto consumptions, we are sharing the electricity produced on these 2 production sites with 6 other buildings, so 8 buildings in total. We will be increasing the number of installations in the next couple of years by about 3 or 4 in collective self-consumption, and we'll also be increasing the number of consumers, because there is a very specific thing of being the ownership of the building needs to be concentrated. Otherwise, you have to create another identity or another organism or another organization to do the billing, do the invoices. So that's a little bit tricky. So that's the reason why we are waiting for some changes at the regional level, which will be done by, I think, 2022. With the help of Région de France, to have a collective PMO. PMO is Personne Morale Organisatrice. So we are waiting for that to happen to massify this technology in our at Fourmies. So some of the statistics, it's been 3 months that we have started the production through this dispositive of collective self-consumption. We have already produced about 6 megawatt hours in total from these two power plants. We have had through the statistics provided by the energy producers or the gestionnaire de réseau, ENEDIS, or the network handlers, we have the percentage of auto consumption at about 100%, and we are having we have already realized an economy of about 1,000 euros over the past 3 months. So that's quite interesting. So the next project I would like to present is from the Métropole Européen de Lille, who are actually storing the electricity in batteries, in solar batteries, and also using battery-operated vehicles. So this is an example of solar installations which was constructed for the project SOMEL So Connected. So this concerns a PV plant of about 40.8 or 41 kilowatt hours of installed capacity with about 136 panels of 300 watts each. Actually, the energy is used for 3 purposes. The first is directly charging the battery-powered electric vehicles. The second is charging the batteries through DC-DC or DC-AC hybrid inverters. And the third is sending the electricity directly into the grid when the batteries are full or there are no cars at the charging point. So the electricity is sold back to the distribution sector. The installation has 12 charging points or 6 installations of charging installations divided into 3 color schemes or 3 pricing schemes. The green one, which is from 3 to 7 kilowatt amperes. The second one is from blue, from 11 to 22 kVA, and the third, which is orange, is from 22 kVA. These different power levels are managed through different tarifications and the EMS system, the energy management system, to optimize the consumption pattern and increase and maximize the auto consumptions, and to help them being stored efficiently in the car batteries. So we know that for some cars like Renault Zoe, the battery capacity varies from 40 to about 52 kilowatt hours. So they can be charged if they are being connected to the green ones, they can be charged progressively in 3 to 4 hours. So during that time, the energy is directed towards the cars, and the energy is being stored in the car batteries. So it's also quite an interesting example of how the storage can be done using car batteries, not just solar batteries, of which the capacity is 65 kilowatt hours actually in this installation. So that was our presentation of presentations for the day, and I would like to thank all of the participants who joined for this meeting, and also I would like to join all the SOLARISE partners to thank you all for making to this session. I would like to thank all the speakers for giving their time, for their energy, and for their expertise regarding this project and this conference. And I would also like to thank Jörg, if he can turn on his camera, because he has been a backbone for the organization of this event. He's from yeah. Yes, Jörg. So he's the one who handled the organization at the back end of this meeting. So thank you a lot. For information, the presentations and the video recording will be available to all the participants in some time. If one of your question was remained unanswered, it will be answered in the minutes of the meeting, or it will be inserted in the presentations which will be sent to you. So thank you for joining us for the event, and have a nice day, and take care, everyone.
Arpan,
Yeah.
I would also like to thank you for this technically challenging webinar to moderate it perfectly. Thank you.
Yeah, it was actually a little bit tricky, and I would like to apologize to everyone who participated and had to undergo some of the technical difficulties. So thank you and goodbye.